Here we go, alkaseltzer lab number 3. We're actually going to start on part 3. Look at that coincidence. This is where we're going to do different concentrations of acid. So now hopefully in the back of your mind, you're thinking something like, acids. Acids have different concentrations. We've gone over that a few times. In fact, this one is a high concentration. On your sheet, it says 1 molar. I'm actually cheating here a little bit. I did 2 molar since I'm all alone. Can do a little bit more dangerous. And then this is a diluted hydrochloric acid. It's around 0.1 molar. So it's 2, am I doing this conversion right? 10, 20 times less concentrated, but it is still an acid compared to our water. Same amounts of liquid. Let's see what happens in this experiment when we add a whole tablet to each one. Remember, before I start, you should make a prediction every time. You should have done your predictions. And then let's see if they're right. So start your timer in 3, 2, 1, go. Started my timer as well. So this one's kind of interesting. This one surprises students a lot as well. So as we pay attention to these, we can see effervescence happening. We can see some awesomeness happening. But you really would think that acid would go fast, would go super, super fast compared to the normal. Well, it turns out that effervescent tablets actually like to interact with water. They actually want more water. They're more likely to interact with the water. In fact, hydrochloric acid is still mostly water at these concentrations, and that's what it's reacting with. So this 2 molar hydrochloric acid is actually going to go a little bit slower, it looks like. Yeah, it actually went a little bit slower than our baseline, reminding you that the baseline of just water took about 50 seconds. Our less acid is actually going faster. It is ending right now at 60 seconds. And our 2 molar, our really concentrated acid, is still going. 70 seconds, still going. Something like 75 seconds, it's finally done. So even though this has a lot of acid in it, it has less water. So the concentration of water actually went down. I tricked you. This one went slower because there's less water. This one went medium because there's some water. And our baseline of water worked the best. So hopefully that one threw you for a little bit of a loop. It typically does. Rinse out one of my beakers here and do our last one. Set this one to the side, which is just stirring. So this one I actually don't need to do a baseline, but I like to just because it's effervescence, and effervescence is fun for me. So if I move my camera a little bit, I hope you can see. Yeah, there we go. I actually am cheating. I have a stir plate here. So instead of me trying to stir it, which is funny for the students to watch, this thing's going to stir it for me. And let's get this one going. So I have 2 whole tablets again. Oops. Maybe. So you want that stir going just right for the size of the beaker. There, that's looking pretty good. So water in both. This one's being stirred. This one's not. 3, 2, 1, go. So reminder from notes that stirring adds mechanical motion. It actually moves things around more mechanically. That's what stirring does. So then we're just kind of watching the paint dry, thinking about what should happen. If we got more motion, what should happen? Who knows? Crank that up a little bit. So remember, baseline, this one should get done in about 50 seconds, give or take. Each time's been a little bit off. And this one should, and there it goes, go a little bit faster, about 45 seconds on our stirred one. Everything is gone. This one's still going strong. In fact, it's taking a little bit longer than normal. And this is where I'm always saying should be and stuff like that. You have to run many trials to get reliable data. Happens around 60 seconds this time. Oh well, still get some pretty good data across our lab. Then the last sheet